13.3 complements and unions of events. So this is the notation for complements. So let's put this in words. The probability of what you want plus the probability of what you don't want is equal to 1 or 100%. So an example of this would be the probability it rains plus the probability there's no rain is equal to 1 or 100%. So it's a 100% chance that it's going to be raining or not raining. When working with probability, sometimes it's easier to use a complement as opposed to just computing the probability directly, but that just varies by problem. Okay. Now some of these, they are going to want you to use the complement, but it's easier just to do it directly. So if there's a 1 in 3,500 chance that you will pick the numbers correctly in tonight's lottery, so the probability that you win is going to be 1 in 3,500. So what is the probability that you will not pick the numbers correctly? So the probability you lose is going to be 3,499 over 3,500. And you can put that in your calculator and convert it to a decimal. So let's look at that. I put it in and I converted it to a decimal. And again, on your homework, just make sure underneath the box where you put your answer to see if they want a decimal or a fraction. If they want the fraction, you'll see the word fraction. If not, they will tell you how many decimal places they want. If 5 coins are flipped, what is the probability of attaining at least one head? So I'm going to make some notes here. I would not write these down. So at least one head means the probability of one head plus the probability of 2, 3 heads, and so forth. Now within that, the probability of one head, there's many different configurations. Okay, and so forth. The probability of exactly 2 heads, so the T, let's do H, T, T. I mean, there's so many different configurations and so forth. So you would have to do that 5 times and then add those probabilities together. The only probability that's not in here is the probability of no heads. It's going to be easier to calculate that. So the probability of at least one is going to be 1 minus the probability of no heads. So that's the only configuration that we have that is not included in this. So at least one means 1 head, 2 heads, 3, 4s, and 5s. So you're going to do 1 minus the probability of no heads. We're going to pull from chapter 12. Okay, you have 5 coins, and each coin has 2 possible outcomes. Okay. 3, 4. Let me get this right. All right. So 2, 3, 4, 5. So there's 32 possible ways to arrange the 5 coins. Of those, there's only one way to arrange it with no heads. That would be all tails. So we're going to do 1 minus what we don't want. And I will convert this to a decimal. I think most of these are decimals. So 0.97. The probability that your DVD player breaks down before the extended warranty expires is 0.015. What is the probability it will not break? So the probability doesn't break is equal to 1 minus the probability it breaks. The probability it breaks before the warranty expires is 0.015. I hate adding and subtracting decimals. So 0.985. This would be an example of one where they don't give you how many decimal places you round it to because they know the decimal is going to stop. The next thing we're going to look at are unions of events. So the probability of E or F, okay, that's a union, is equal to the probability of E plus the probability F minus the probability of E and F. That is an intersection. So let's look at an example. So say we have a class of students, and let's see students that are nursing and students that are female. All right. So we have Cynthia. Cynthia is a female student, but she's not a nursing major. We have Devin. He's a nursing student, but he's not female. We have Crystal. Crystal is a female student and she is a nursing major. Okay, so we're going to fill some other people in. All right, we'll just leave it like that. So let's let female be E and nursing be F. They like that notation, E and F. So we're just going to put it in a context. So the probability that the student is nursing, oops, let me go back, female or nursing. How many would that be? Okay. You count it up, we have female, there's 3 females, and 1, 2, and 4 nursing students. But if you count up all the students, that is not 7. We have 1, 2, 3, 4, 5. So what's the problem here? What happens is you're counting Crystal and Helen twice. So we're going to add the female students plus the nursing students. We said there were 3 female, that down here, plus 4 nursing. And we're going to subtract out the students that are female and nursing. So there's an overlap right here. So that gives me 5. So I count up the students. There are 5 students, so it comes out correctly. So with the unions, we need to subtract out the overlap, is what we're doing. This one has the notation. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Okay. We have A union B. A is just 0.6. B is 0.65. And then we need to find A union B. So this is what we're looking for. So I'm just going to put an X. From here, you can use your algebra skills to solve this. You can use the numerical solve if you're familiar with that calculator. Divide out the negative. So x is equal to 0.35. And again, probabilities have to be between 0 and 1. You can't have negative numbers, and you cannot have anything greater than 1. Let's look at another example. What is the probability of getting either a club or a queen when drawing a single card from a deck of 52? So it's the probability of a club plus the probability of a queen minus the probability that it's a club and a queen. Okay. So the probability is a club. How many clubs are there? That's a whole suit. That's 13 out of 52. The probability is the queen. How many queens are in a deck of cards? Remember, you can pull up that image if you need to. Okay. So that's going to be 4 out of 32. And now, are there any 52? I'm sorry. Now, are there any that are clubs and queens? We have one queen that is a club. So that's 4 over 13. Or 0.31. So 31% chance that you're going to draw a club or a queen. So again, just see if they want a decimal or a fraction on that one. If we randomly select a worker, what is the probability they are under the age of 55? So under 55 does not include the 55 to 64 range. Right? So again, you do not include 55 because it says under the age of 55. Under 55 is 54 and below. Most students don't like to use the complement on this. So we're going to take what we want is the ones that are under the age of 55. And then put that over the total. All right, I'll get a couple numbers. Take me a second. This is not a special function on the calculator, so I'm just going to do it on my handheld real quick. 1369. $14.83. And I am going to convert this to decimal. I just like two decimal places again to see how many they want. So 92% of the workers are below the age of 55. Your car's windshield wipers have not been working properly. The probability you need a new motor is 0.55. So the probability you need a motor is 0.55. The probability you need a new switch is 0.4. And the probability that you need both, the probability you need a motor and a switch, is 0.15. What is the probability that you need neither a new motor nor a new switch? So it's going to be a little two-parter here. What we're missing is the probability you need a motor or a switch. That's going to be our X. So the X comes first. That's your OR. We have the motor plus the switch minus the overlap. So probability you need a motor or a switch is going to be 0.8. What we want is the probability you need not a motor nor a switch. So that's 1 minus the probability you need a motor or a switch. 1 minus 0.8 is going to be 0.2. So the probability that you don't need either one of those is something completely different other than a motor or switch is going to be 0.2. 20%. A survey of consumers shows that the amount of time spent shopping on the internet per month compared to their annual income. It says see next slide. That's just the chart. If we select a consumer randomly, what is the probability the consumer shops on the internet 10 or more hours per month or has an annual income above 60,000? So the probability they spend 10 plus hours on the internet or their income is above 60,000. So probability they spend 10 or more hours per month on the internet plus the probability their income is above 60,000 a year minus an overlap. That would be the people that spend 10 or more hours per month on the internet and have an income above 60,000. So the probability they spend 10 or more hours per month on the internet is this column here. They give you the total. Okay, so 543 spend 10 or more hours a month on the internet over the total, which is the 1810 that's down here. All right, so the probability they have income above 60,000 is here. So that's 548 people have incomes above 60,000 out of the 1810 that were surveyed. Now, where is the overlap? All right, so this one's pink and yellow. So we have 215 people that spend 10 or more hours per month on the internet and have an income above $60,000 a year. Okay. So I'll put this on my little handheld here. You are going to need this as a decimal. I'm going to use 3 decimal places, not for any particular reason. So 484. They may ask for 2, they may ask for 4. Just read the instructions. I believe this is the end. Yep, that was the end of 13.3.